Yeah, apologies for all. And this is, we are back. And please, Kimmo.
I'm back in the room, yes. Thank you. So, my first two PhD students when I came to Mälardalen University was Andreas Rive and Pontus Strimlin. And they have both turned out to be brilliant researchers and more visionary than me. So they have enormous grants, so they hire me. So I don't have to apply for grants. I just go on their grant. And I think anyone can use that trick. So the usual, most of my work I do with Pontus, but today I'm going to speak about the work that I've done on the grant of Andreas. So Pontus, as you know, he's these days a social scientist, although formerly a mathematician. Andreas is a professor of mathematics education. He once said to me at the Christmas dinner at the Institute for Future Studies that he had some interesting Swedish data from TIMSS. And I didn't know what TIMSS was, so he didn't explain, and he said that he wanted to hire me on 20% of my time to work with that data. So what are these kind of data? International assessments of student achievement. Well, the most famous one is PISA, stands for Program for International Student Assessment, and that's the OECD organization that does that. So it's an assessment that's absolutely enormous. You do it every 3 years. It's always more than 50 countries. Last time I think it was 77 countries, with representative samples of students, of the 15-year-old students, and these samples are huge, more than 5,000 students per country. And some countries go all in and have like 20,000 students. And they do 3 tests. So these poor 15-year-olds have to do a long math test, a long science test, a long reading test, and fill in an absolutely horrendously big background questionnaire. Not only them, but also the teachers and the school leaders fill in background questionnaires. Then there's this TIMSS one that Andreas wanted me to work with. That's Trends in International Mathematics and Science Study. That's run by another organization, the IEA, which is more scientist-based. They also do a very similar setup every 4 years. They also have around like 50 countries, also huge samples. They do it in 2 grades, both 4th grade, like 10-year-olds, and the 8th grade, so like 14-year-olds. Math and science, as you can see in the name, and also these background questionnaires. The most interesting difference between these two is that these 2 entire classes, whereas PISA does a sample of individual students. So we instead have a representative sample of classes. That means that we can also examine class level variables here. And then the third one I'm going to speak about is called PIRLS, Progress in International Reading Literacy Study. So that's about reading. So you can see that TIMSS and PIRLS together cover the same topics as PISA does, math, science, and reading. And if you think about it, it's no coincidence. It's just that these 3 are the things that it's very reasonable to check across cultures. Whereas, you know, language studies will be different in different languages, and social science systems will be different in different countries. And the PIRLS study is every 5 years. These are not only amazing studies, but the data is publicly available for everyone. You can just download it from the web pages. So it's an absolute fantastic resource for people who are interested in education and achievement, of course, but you don't need to bother about that. You can only look at the background questionnaires, which has loads and loads of interesting questions in them. So what can you do with these kind of data? So, for example, you can look at how achievement develops over time. That's something that Karen and I spoke about at lunch today, that Hungary was declining over time. So what has happened in Sweden? Well, Sweden also had a very famous, in Swedish media, decline in PISA, the TIMSS results in this case. until about 10 years ago. And then there's been a bit of a rebound. And one curve is for mathematics, the other one is for science. You can see it's the exact same shape for both. TIMSS is seldom discussed in Swedish media compared to PISA, but PISA shows the exact same pattern. Back in 2000, 515 points on this PISA scale, then going down to something like 485, and then a bit of a rebound. So these curves are very interesting in themselves. One thing that they show is that we have the exact same pattern across subjects. That is interesting because it eliminates some explanations for why these things happen. So, for instance, the politicians who were in charge at this time like to say that, well, the math results increased because we had a program called the Lärarlyftet, Boost for Mathematics. We had a huge investment in professional development for math teachers. But that really can't be the explanation, right? Because that won't have affected the science teachers or the Swedish teachers. And in fact, I've done another analysis of the Lärarlyftet and it's showing exactly zero effect on achievement, although it has some effect on what teachers do, but it doesn't have any effect on what the students do. Another thing is that even if we had a bit of a rebound, don't seem to be as good as we were back in 2000. So, or even 1995 seems to be even better. So was that the golden age? Well, if you ask me, I was a teacher at KTH in 1997. That time I was in charge of remaking the diagnostic test for the beginners at KTH. So KTH is the biggest technical university. Why do we have to remake the diagnostic test? Because at that time, results had fallen so badly that at some programs, students didn't perform better than random. No, it was, so you can't really use it for diagnostics. That was in the golden age, suggesting that when we created the previous test that was then so poor, it must have been the golden age in the 70s. So what had happened in the meantime? Probably only that university education had expanded so much that previously it was just the elite of the elite that went to KTH. But in 1995 it was just the elite. And the elite is so much worse than the elite of the elite in achievement. So what these curves do not show, this is my point, is that this is only in the mean. There's also a huge individual variation. So the poorest students in Sweden are down here, and the best are up at the word use. So this is just average achievement. Okay, another thing you can do with this data is compare countries. So the whole point with having waves is compare across time, and the whole point of making it international is to be able for countries to compare themselves against each other. So let's look at PISA data. Here I have mapped on this every dot is a country. On this axis, we have mathematics result on average. And here we have reading achievement on average. So the first thing to note is that these are almost perfectly correlated. A country that is good at mathematics is also good at science and at reading. That's also very interesting because it shows that it's not how well we teach mathematics specifically that determines Sweden's achievement level. Because, that can't affect the reading results, which are exactly the same. Okay, another thing that what is it that determines country? Well, if you look at the top here, it's China, Singapore, Hong Kong, Korea, Macau, and Japan. They also have something else in common. Right? They in the same corner of the world. So clearly there's a very strong cultural component in this. Cultural in some sense, we can't just say from that if the student's culture, or if it's the parent's culture, or if it's a culture that's behind the school systems. But clearly, at least, there's something that culture does. Sweden is, at around 500, so one of these dots here. The other dots here are essentially Europe. And then we have Latin America down here, and we have Africa and Middle East down here. So it's very, very regional, this country variation. So what can you do more? Well, you can try to understand it. So what is it that predicts student achievement? We can look at the country level, for instance. Then we have these things I mentioned. Could be cultural values that are behind this. It could be differences in the resources we pump into the system. Or it could be something about how students are treated, for instance, based on gender. But that wasn't what Andreas hired me to do. Andreas hired me to do work with class level things because he's professor of mathematics education. He wanted to know what are the teaching practices that are effective. So then we can look within one country, compare teaching practices from the questionnaire to the teachers and questionnaire to the students, and then see, are good class achievement characterized by certain practices. Another thing we can look at is textbooks. So usually we don't know what textbooks that are used in different classes. But Andreas managed to get the TIMSS in Sweden to add an extra question. Which textbook are you using? So that's a possibility for these, that you can add national editions. You have to go to Skolverket and persuade them. So I have one finding here that I can just briefly mention because it's never been published, but it's quite interesting. So there are, there were at the time, this is TIMSS 2015, essentially 2 math textbooks that were in use in Swedish schools. There are like 5 or 6 differences, but 2 that are actually used. So one question one could ask is, what is behind teachers' choice of which of these textbook series? And one hypothesis is that, well, maybe one of them is regarded as easier than the other. So you would use that in classes that are socioeconomically weaker. That turns out to be true. So one of them was clearly used more often in socioeconomically weak classes. But then the second question one can ask is that a rational choice? Does it matter for the weak students which ones you choose? Turns out that it doesn't. The weak students do exactly as well with these 2 books, but clearly teachers had a preconception that one of them would fit better. The reason we haven't published that is that you would also like to complement it with teacher assessments of the books, but we never had the time or energy to actually ask teachers, why did you choose this or that? So it's just a hypothesis that they based it on whether it was easy or difficult. But anecdotes tells that it is. But most research using PIMSS and PISA data are focused on the student levels. So we can look at gender differences or socioeconomic differences or differences in parents' attitudes, for instance. So Andreas hired me to do that stuff, but when I had done that, I asked, can I continue working on your money to do whatever I want? And he said yes, because he had so much money. So I have worked on the student level predictors in interaction with the country level. So then I don't need to just use TIMSS data, but I can use PISA data as well. So that's what I'm going to speak about now, that kind of stuff. Student level predictors in interaction with countries. So here's the first, most obvious case I was interested in. There are gender differences in academic achievement. Does that vary across countries? And if so, is there some systematic pattern to that? That was my original idea. Then I started to look into it, and some other people have also come up with that idea. And done quite well, I would say. So these were the 2 first studies that focused on this. We have Guiso et al. In Science, cited more than 1,000 times, and Elsequest in Psychological Bulletin, cited more than 2,000 times. These are very, very influential papers. So what did they do? Well, Guis et al. Said that the PISA results suggest that the gender gap in math scores disappears in countries with a more gender-equal culture. So then you need to know that there is a gender gap to begin with that favors boys. So boys tend to do a little bit better than girls in math on average, but that gender gap disappears in the more gender-equal societies. And then we have this SES-gender paper, Cross-National Patterns of Gender Differences in Mathematics, saying the same thing. Coming out 2 years later, so why is it cited more? Well, probably because SES also has a strong theoretical idea for the same finding. So here is what the SES paper is about. First, there is a gender gap in math. Girls tend to achieve worse than boys on average. Okay? And then that's a phenomenon that one would like to explain, right? And this is the explanation. There are gender inequalities in the job market. And that will negatively affect girls' motivation in mathematics studies. And then this is the theory that is then supported by their analysis, because they find that the size of the gender gap is negatively correlated with female participation in the workforce, as well as with female political empowerment, which is really the ratio of female politicians in parliament. Which, of course, is a quite fragile measure. I mean, it fluctuates between years, much more than the female participation in the workforce. So that was literature before I did my own work. So I want to discuss a couple of pitfalls that this research had fallen into. The first one is not examining more than one domain. So you see, it was all about mathematics. All the arguments were about mathematics, and the analysis was about mathematics. But here is what the gender gaps actually look like in the three subjects that these assessments test. Mathematics is above the zero line, means it's favors boys. Marginally, it's like maybe 7 points on average on this. Science is almost exactly gender neutral. Reading is a huge gender gap in the other direction. So in every country in the world, girls have higher achievement in reading than boys, and much, much, much more so than this gender gap in mathematics, which is small on average, and in like 1/3 of the countries, it's on the other side. So the take home here is that the gender gap in mathematics is not the big phenomenon here. The big phenomenon is clearly the reading gap. We can also look at what this country variation looks like in both reading and math. So every dot here is now a country. And you can see that the positive numbers here means that the gender gap favors boys. So about 2/3 of the dots are on to the right of the zero, and 1/3 is to the left. Here we have the negative numbers consistently means that the gender gap favors girls. There are a few countries where the gender gap is not so big, and then some countries where the gender gap is really big. So what I mean by really big here, well, you should know how big is the standard deviation within a typical country. It's 80 points. So a gender gap here of 60 points means that it's a 3/4 of a standard deviation. It's a gender gap, that's a huge effect. So the gender gap in reading is comparable to the gender gap in throwing, which favors boys, which is one of the biggest gender differences there is. Whereas this, in mathematical achievement, there's really no reason to speak about a consistent gender. But the main point here is that the country variation is very similar. What does that mean? It means that when boys improve compared to girls in mathematics, boys also improve compared to girls in reading. So any explanation that focuses on something specific to mathematics seems to be eliminated, because country differences are the same across subjects. Okay, it's another pitfall. Not examining several waves. So it turns out that both these celebrated papers use the same database. They're not strange that they found the same result. They looked at the same data. PISA in 2003. So they both found these negative correlations between gender equality and the gender gap, when the gender gap is coded positive for boys. But of course, Else Quest published her paper in 2010, so she could just as well have chosen to use TIMSS 2003, PISA 2006, TIMSS 2007, or PISA 2009. But none of those waves would have supported her thesis. Because it's just very, very specific to that data set. She wouldn't have had access to what happened after 2010, but we have. So we can see that the opposite trend just continues. So typically, there's a positive correlation between politics equality and gender gap. Probably positive for boys. So the question one should ask is, why do we get these different results? And there are two reasons. First reason is that every sample of countries is not the same. So in PISA 2003, it was a relatively small sample, and that sample turns out to be rigged well, not rigged, but it helps very much the correlation that they wanted to have. But the other reason is that gender differences are typically small, in particular mathematics. So even though these are huge sample sizes, finding a gender difference that is small needs to be measured very precisely. So you would like to have even larger sample sizes than 4,000 per country. So there would be quite a bit of noise in those data if you just look at one way. And so I looked at these to see, does it seem to be any genuine change in these gender differences across time? The data is perfectly consistent with there being no genuine change, which suggests that we can just pool all the data from all the ways and see if we can get a clearer picture of what's happening. So that's what I did. And then you find that the math gender gap is in fact not correlated with workforce equality at all. It is positively correlated with equality in politics, but it's strongly positively correlated with gender egalitarian values from other data sources, World Value Survey and the Globe Survey. So that's a measure where we asked loads of people in the country what they think about, should men and women have the same right to jobs? Should men and women have the same right to go to university? So it turns out that the more gender egalitarian a country is in the value sense, the better boys do compared to girls. So this is directly contradicting those findings that gender equality somehow is the recipe for saving girls. But also we know that girls don't need saving, because if you look across the three subjects, in fact, girls had a gender gap in favor for them. So what we can say is that gender equality does eliminate the total gender gap, but it just it was the wrong sign of what the gender gap was in the first place. So I will summarize the pitfalls at the end. Those are two of them. Now, another study I did, socioeconomic gaps. So we also know that socioeconomically advantaged students perform better in school. But does that gap also vary across countries? So this is a picture I took from a recent paper, Brewer et al., looking at the difference in mathematics scores between high and low socioeconomic status students in TIMSS. And these are different countries. So for instance, squares of Hong Kong. Hong Kong is at the bottom. That means that the socioeconomic gap was quite small. And then we have this is it's Hungary. So it turns out that the socioeconomic gap in math is quite big in Hungary. And you can see that there's a bit of noise, but a very strong consistency that some countries tend to have smaller gaps than other countries over time. So clearly there's something here that you'd like to understand. But first, what do they mean by socioeconomic status here? Well, this star is the author's star. Going to this footnote, saying that this CS measure is a modified version of the TIMSS composite measure for socioeconomic status, which does not represent the full socioeconomic status construct as usually defined by parental education, family income, and parental occupation. In fact, what it is an index based on parental education, parental occupation, and things that are in the home. So that supplements family income. So I would still say it's very close to whatever they wanted to do here. But I have major quibbles with this idea of socioeconomic status. So this is the third pitfall then, the idea that you can just use a composite measure of socioeconomic status. Why? Well, because it is not a latent variable, right? It's not that some people have a high socioeconomic status, and that is expressed in that they have high education, high income, and high occupation, high status occupation, high wealth. That's not how it works, right? It's exactly the opposite way around. That if someone has high education and a high status occupation, we would summarize that as they having high socioeconomic status. But doing that kind of summary is only good if it's, if it's reasonable. But how do we know that it's reasonable? It might very well be that different socioeconomic variables have different effects on achievement. For instance, what can you do with wealth to improve someone's academic achievement? You can buy tutoring, for instance, put someone in an expensive private school. Those are things that require specifically wealth. There's no benefit of having a high education for doing those things. Whereas having a high education is very good for other things you can do. Like you can do homeschooling, you can teach your children things that you know, which wealth is useless for. So if you actually want to understand, and it turns out that in this literature, there's enormous amounts of studies looking at socioeconomic gaps in education, and almost no studies trying to understand why, what the pathway is. And I think one reason is that they don't differentiate between different aspects. But here's another reason that composite measures are bad for this, is that you will then underestimate the problem. If you just bulk them into one lump, you will not know how much variance in achievement is actually explained by socioeconomic factors. To do that, to know that, you need to look at them as independent variables. So here's a study I did using the PISA data from 2018. So then you have 77 countries. Countries here as shorthand for countries and regions. So some of them are like Hong Kong, it's not actually a country. And there are also some like French Belgium might be its own entity. So PISA has a socioeconomic status composite measure, or the ESCS, which has these 6 components. Parents' highest occupational status, parents' highest educational level, the highest of the 2 parents. Wealth possessions, cultural possessions, home educational resources like you have internet, and the number of books at home. So they weighted together, that's 1/3, that's 1/3, and these 4 together are weighted together, and then it's 1/3 of that index. So first I want to demonstrate that if you use that index, you will underestimate the socioeconomic achievement gap. And I will demonstrate that simply by constructing another measure of socioeconomic status. If you just take parents' occupation and books at home, then you'll find that achievement gaps are bigger than when you use that composite measure from the PISA had. So we can just look at this part of the graph. So by the achievement gap here, I mean the difference between the low first quartile and the third quartile, so the interquartile gap. And the white bar is that achievement gap estimated using the PISA index, and the gray bar is if we instead use just occupation and books. So you can see that these are consistently a bit higher. And if you look at the countries where you have the very biggest effect of the PISA index, turns out that then you get an even bigger difference between that index and this index based on just occupation books. So there was a meta-study of socioeconomic gaps in education came just a few years ago. And that has the message that these gaps are surprisingly small, in fact. I say that you can't really draw that conclusion from a meta-study because if some measures are bad at capturing the socioeconomic gap, then that will just come into flaw your meta-analytic estimates. So why does my index with 2 items work better than the PISA index? It's because these different variables actually have very different effects on achievement. So these are the results from just doing a multiple regression, using all these 6 as independent variables, doing that separately in every country, and then I have the average effect across countries here, and the different colors are for the different subjects. So first you can see that it doesn't matter if you look at mathematics, science, or reading, you have the exact same pattern everywhere. So the 2 big contributors to achievement are parents' occupational status and books at home. And strikingly, wealth possessions, which is the best index to capture the wealth of the family. So the question here is then, how many cars does your family have? How big is your house? And things like that. Well, the effect is essentially 0 for wealth. But this is on average across countries, right? So now comes the really interesting part. These things vary across countries in a very systematic way. So the effect of wealth is 0 on average, but it's not 0 in every country. These countries over here, Indonesia, Dominican Republic, Lebanon, Panama, Peru, they have huge effects of wealth on achievement. Here we have Western Europe. That effect is actually negative, consistently negative. So on this axis, we have a human development index. So what this graph actually tells us then is poor countries, wealth matters. In rich countries, wealth, at least the independent effect of wealth, is, if anything, negative. One explanation could be that in Sweden, you can't actually buy better education by investing in it. But in Indonesia, you can. That's at least the intuitive mechanism you could think of from this graph. Okay, how does it then look if you look at the effect of books at home? So the effect of books at home was, as you saw, the biggest of them all, but it's not large everywhere. In countries like Indonesia, here we go again, Dominican Republic, the effect of books at home is almost nil. Whereas if you look here in Western Europe, the effect is huge. So books at home has a large effect in rich countries, and it has essentially no effect in poor countries. The exact opposite to the effect of wealth. And this is not just an artifact of doing multiple regression. If we just look at the doing simple regressions for each variable, we get the exact same. Because those socioeconomic variables are in fact not very strongly correlated. So my conclusion from this is that it can be actually very revealing from a theoretical perspective to actually understand what's going on, to separate socioeconomic variables in analysis, rather than lumping them all together in one index and then just only use that. Okay, so what could now explain this variation across countries in that effect of books at home? Well, first you'd like to understand, why do books at home have a strong effect at all? So why does any socioeconomic variable have a strong effect on achievement? Well, as I said, these are very poorly understood things. It's particularly poorly understood for books at home. But there was a paper by a Swedish sociologist just a year ago, Eriksson. He argued that, well, the effect of books at home is actually an artifact, because it just represents reverse causation, that low achieving students underestimate the amount of books at home they have. So if they do that, low achieving students underestimate the amount of books at home, then it will look like you have few books at home, it is correlated with achievement, but it's just an artifact. Okay, a problem with that is that, well, and you can see that in his own paper, that the estimated effect on achievement, if you use parent-reported books at home, does not weaken. That's a very, very strong argument that actually that this seems to be a very genuine effect of books at home. It's not just a statistical artifact, an artifact of the bad reporting. So if you look closer, you can see that his analysis is flawed, and it's not the fact that low achieving students underestimate the amount of books at home. But what's really happening is that they estimate the number of books at home poorly, which makes a lot of sense. Who are these low achieving students? Well, they are students who are not so good at, not so strong cognitively. One cognitive thing, like, for instance, you can even use it in the PISA math test. Includes exactly estimation tasks of the exact same kind, like estimating the number of books at home you have. So there's every reason to think that it's not so easy to estimate the number of books at home, and particularly difficult for low achieving students. So they will have more errors in their estimates. And that means that we will have two, so this is funny for a mathematician at least, two simultaneous associations. We have this association that for some reason that we don't know, if you have more books at home, you will have higher achievement. But this, where we actually have a very clear mechanism. If there's more error in your book's estimate, you probably have lower achievement. So how can I prove that this is true then? I have found this way of showing it. So on this axis, we have the number of books at home according to the parent. And now this gray line is students who say that they have loads of books. Okay. So I am a student who say I have loads of books. My parents say I don't have any books. My achievement score is very poor. In line with this, that I make a lot of error. Okay, I'm a student who have a lot of books. My parents agree I have a very high achievement, right? because I have indeed a lot of books and I didn't make an error. Now look at these guys, the guys who don't have any books according to themselves. If they don't have any books, the parents agree, well, you have a low score, but not as bad as if you also did it. If you don't have, if you say you have few books and you in fact have a lot of books, you also have a low score because you now have two effects that counter each other. You do have a lot of books, but you also make a very big error. So this is a beautiful way of just adding two effects. What happens if they go together or not? So here comes. So I made up in my paper a sociological argument for why we would see the difference that richer countries, that books at home would be more important in rich countries. But then I realized that I had also fallen into the pit. So that finding is instead an artifact of differences in data quality. So this is what the remainder of this talk will be about. So we have this. We now use PITFALLS data where you find the same effect here. If you have a high development level in the country, you would have a strong association between books at home and their students. The correlation between those two measures is 0.42. Okay. Now, what characterizes countries that have a low development level? Well, for one thing, they also have low achievement scores in PISA and TIMSS and PITFALLS. And we know that low achievement scores means that you're probably worse at estimating numbers of books. So, and indeed, it turns out that this thing mediates that relation. We can then also look at the accuracy of these estimations. How can we measure the accurate estimations? Well, simply by taking the correlation between parents and students' estimates of the number of books at home. And it turns out that that mediates this. So we have a clear path here. Rich countries have students achieve better, they do better estimations of books at home, and that's the reason why we see a strong correlation. Or rather, if you have a poor country, they will achieve poorly, and among other things, they will do poor estimation of books at home. That means that they have so much noise in the data that this association disappears. So this just fully mediates this the original finding. So it turns out that my sociological explanation isn't required. You can just see that there's country variation that we had over here is just an artifact of that. Then the critical reader might think, or listener in this case, is this also an artifact of the same thing, the effect of wealth? But then if you think about it, you really probably this effect is just stronger then. If they also are worse at estimating how many wealth items they have over here, that means that in reality, these wealth effects should be even bigger. So in this case, if there is a problem with data quality, we should just see an even bigger gradient of wealth. When did we start?
Yeah.
3:30. Yeah, yes.
Yeah, so.
Yes, so I will go on for 8 more minutes then.
Yes.
Yes. Okay, so last thing, the interaction of gender and socioeconomic status then. So many authors, or at least several authors, have suggested that boys should have a bigger socioeconomic achievement gap than girls. They should look like something like this. They have achievement on that axis. That the socioeconomic gradient is steeper for boys than for girls. Why? Well, for instance, if you think about investing economically in your child's education, that requires two things: that you actually have the means to do it, that means that you're rich enough, and the other, that you want to do it. So the idea then is that people are more willing to invest in boys, parents, than in girls. So then we will see exactly this kind of interaction. That, yeah, if you both have the means to do it and you want to do it for boys, you will get a steeper. Gradient. Okay, so what does it look like? Well, if you look in Tim's data, these are just graphs that I made up to illustrate, but it looks like this, that you actually find this result. I found this last summer, and then I got really confused, because then I looked at the PISA data, and there I found the opposite result. That the steepest socioeconomic gradient was among girls, not among boys. And I called Pontus, and we discussed the possibility that things happens in puberty, that differences is different between boys and girls. We know that things happen in puberty are different between boys and girls. Could this be it? But then I realized that maybe I had just gone into the same pitfall again. That in fact, this is also an artifact of differences in data quality. Because where do we get this socioeconomic status data from? In this case, it's parents' education. Well, in Tim's grade 4, we get it from the parents. But PISA asks the students, because they are 15-year-olds, so they should be able to answer that kind of stuff. So how can we settle if that is the problem? Well, turns out that there were 2 PISA waves in the days of yore, when they also asked parents about socioeconomic status, parents' education. So then we can compare what it looks like if we use student-reported data or parent-reported data. And it turns out that then the whole thing shifts. So that was just an artifact of using student-reported socioeconomic status data. If you ask the parents instead, we replicate the result, and the gap is bigger among boys than girls. How can we illustrate that then? Well, we can just look at what is the proportion of incorrect data. So we should, I really call it incorrect here, because parents should know their own educational level. Whereas students can only know it if they learn it from their parents. All of that happened before they were even born. So girls are the white ones. They have about 10% error in their idea about whether the parent has gone to university or not. Whereas the boys is about 13% on average. Don't know that. In 2006 way, we see exact same difference, but overall lower numbers, which turns out to be, as I see it, caused by 2 things. First, slightly different samples of countries. These are the average across all countries. But the other thing that happens here is that the size of the student questionnaire increased. So here's what I think is happening here. We have these boys who are slightly less self-disciplined than the girls. Here they are faced with a 30-page questionnaire. Some boys just give up and think that, okay, I won't bother, I'll just... Here they're faced with a 50-page questionnaire, and the number of boys who do that increases. So I think one thing we should learn from this is that we should rely less and less on questionnaire data the longer the questionnaire is. But the main conclusion here is that if you have a gender difference in data quality, and I look, no one has ever spoken about this gender difference in data quality. I'm writing that up right now. Because they are big enough to corrupt findings. We saw that. If which gender has the highest socioeconomic gradient shifts if we use student-reported data because of this gender differences in the quality of data. So, what has studies done before? Yes. There are some studies who have actually looked at these socioeconomic achievement gaps in parent-reported data. They have obtained mixed results, I would say on average 0. But they've also only been conducted in rich Western countries. It's been in Sweden and United States and England, Norway, things like that. So, could that be the reason that we obtain the first mixed results? That we don't robustly see this largest gaps among boys and girls in those previous studies. So I looked at the country differences, and it turns out that this is very nicely correlated with gender equality. So where do we find big gaps favoring boys in the steepness of the socioeconomic gradient? It's in this really gender inegalitarian countries: Bahrain, Qatar, Oman, Saudi Arabia. Where does it even flip to the other side? It's over here in Sweden and Finland. So this suggests that in order for these mechanisms that produce the interaction between gender and social composites to be active, you have to have a certain level of gender inequality, which makes sense. You know, if you have the investment story, for instance, you have to have parents that preferably invest in the boys rather than the girls' education. You probably won't find that in Sweden, but you certainly can find it in Saudi Arabia. So I summarize these 4 pitfalls now, because that's what I want you to remember if you ever work with these kinds of data. That it's bad to not look at all domains. They are all there for you. There's no excuse not to look at them. But if you look at them, you might find that your favorite pet theory actually fails. Or you might find it supported, but you should at least check. Second one, all of these waves are there for you to look at. So if you just look at one and find your favorite finding there, just look at one more to be sure, because it might be that it's just that particular way, because we have different samples and things going on. So I honor these things myself now after I found it. I don't typically write it up in the papers, but I check that that things are actually as they should be across domains and across waves. Then we have this pitfall of only using composite measures of socioeconomic status. If you have several measures, which you typically have in these kind of data, you might want to use a composite measure in your paper, but just check that you actually have the same finding, otherwise report different findings of different variables, because that would be very interesting for theorists. And the fourth one is the pitfall that I stumble in myself all the time, that your mysterious findings are very likely, in fact. I think there will be tons of papers out there that are all findings are spurious because they're just driven by differences in data quality. It's because if you have this kind of self-reported data, of course, data accuracy will differ across groups. And maybe they will differ exactly across the groups that you are interested in measuring. Then you have to check them. That was my hour. Thank you.
Thank you very much for this excellent and thought-provoking talk. And then we will stop now the recording just that